and welcome everyone to the LNI Carswell Observatory spontaneous live stream. We are currently looking at the Lunar Regulus, also known as the Moon, awaiting the impact of the Falcon 9 booster, which was calculated to be impacting our moon at some time early this morning, 2:35 a.m. and near Einstein crater, which is the region of the moon that we are pointed at. I'm Dr. Elena Hyde. I'm the director of the Ellen I. Carswell Observatory in York University in Toronto, Ontario, Canada. We are collecting this data with the hopes that it will be useful. And of course, we're hoping as well to see something, maybe a little bit of a plume, or perhaps even a tiny bit of the fireball. In any case, I'm joined by a wonderful crew tonight. We have three other student observers from York University. Let's go ahead and introduce them now. Manish, why don't you start off and introduce yourself?
Hello, I'm Manish John. I have just about completed my first year of physics bachelor's, and it's good to meet you guys.
What's your favorite part of the observatory, Manish?
I've just about come to love the 1 meter telescope. It's so cool to finally see all the deep sky objects for myself.
Absolutely. And next up, we have Nicole. Go ahead and introduce yourself, Nicole.
Hello everyone, I'm Nakul and I'm a graduate in physics and astronomy from York University and I've been at the observatory for a long while.
And what's your favorite part of the observatory, Nicole?
It's of course observing all the night and then doing some astrophotography and having fun.
Wonderful. And finally, we have Hector. Last but not least, Hector, why don't you introduce yourself?
Hello, good night, everyone. My name is Hector Jimenez. I am in my 5th year of astronomy and astrophysics here at York University, and I am excited and happy to see all of you here for this lunar impact.
Fingers crossed, of course. And Hector, what's your favorite part of the observatory?
My favorite part of the observatory is perhaps already mentioned by Manish and Nicole, but I would like to say it as well. All the wonderful things that we have been able to capture through our excellent telescopes. With the 1 meter telescope, we have gotten such an excellent images. So yeah, looking forward to get more beautiful things from the deep sky.
Wonderful. And of course, in the meantime, we do have this Falcon 9 moon impact to look forward to, we hope. Now, I see we have a few more people possibly joining us this evening. So we're just going to open up our Lunar Falcon 9. Of course, we're broadcasting live from the Ellen I. Carswell Observatory at the York University Keele campus in Toronto, Ontario, Canada. We are hoping, of course, to catch as much as we can from this exciting event. And looks like we have a few guests, Bruce and Seneca, joining us.
Good evening, Dr. Hyde. How are you?
Bruce, we were just doing some introductions. Why don't you go ahead and introduce yourself?
Oh, okay. First, certainly, I'm never happy to go first, but we'll do so in this case. My name is Bruce Waters. I'm a former educator at the McLaughlin Planetarium, and I am the founder of the Killarney Provincial Park Observatory in Killarney, Ontario.
Of course, found in the Ellen I. Carswell Observatory Astronomer in Residence program. So glad you
Absolutely.
mentioned that.
So I was waiting for you to say that, but yes, absolutely going to mention that, and very, very excited and pleased to be part of that collaboration as well as being here tonight.
So I noticed we also have another guest with us, Seneca Smith. Seneca, why don't you go ahead and introduce yourself?
Good morning. I'm Seneca. I'm a physics teacher and I'm the vice president of the Barbados Astronomical Society, where we operate the Harry Bailey Observatory. And I will be participating in the Astronomer in Residence program in just a few weeks.
Wonderful. Of course, we're looking forward to seeing you there. And do you have a favorite part of the moon?
Oh, there is a crater, the Graves crater, that is named after a Barbadian, actually. A former president, chairman, leader of the Royal Astronomical Society has a crater named after him.
Do tell.
Graves crater. Um, I forget precisely what area of the moon it's in. I can identify it on a picture of the moon. It's, I don't think, visible from where we're looking right now.
Of course, we're near Einstein crater, so that could be your point of reference. Now I'll go ahead and pick on Bruce next. Bruce, do you have a favorite part of the moon?
You know, I wish I could say so, but it's kind of like having many children. Each children brings different, interesting, and beautiful aspects to your life, and I feel the same way with the moon. Sometimes I like looking at the crater. Sometimes I like looking at the Terminator. Sometimes I just like taking the whole thing in. Sometimes I enjoy tracing out the seas of the moon. No, I don't. I can't say I have a particularly favorite part, but I do enjoy each aspect of the moon. It almost as if it presents a different feature to you every time you look at
Well, it's about to, I hope.
it. Indeed.
And of course, this will be a new crater if the collision is successful, which it does seem like it will be.
Absolutely. Absolutely.
So I've heard a lot of talk recently about the size of the expected collision. Has anyone else heard any estimates about how big they expect the plume of dust to be once the moon is impacted?
The only thing I've heard myself is somewhere in the area of 50 kilometers, and that'd be actually quite spectacular. And I'm also
That
curious,
would
not
be
just to see,
spectacular.
yeah, not just to see how high the plume of dust is, but how concentrated that plume is. Is it going to be very diffuse, or is it actually going to be somewhat opaque and therefore reflect a lot of light and be quite noticeable that way? This harkens back to the time when Comet Schumacher-Levy plowed into Jupiter. I remember a lot of astronomers, including myself, around the world, all had our telescopes aimed upon the planet, really not expecting to see anything. And then we were shocked to see these massive dark blotches of the impact dotting across Jupiter. Now, I'm wondering if we're going to see something, along those lines. Will it be quite spectacular, or will it be very faint? What are your thoughts, Dr.
Well,
Hyde?
I hope we get to find out. I mean, one of the best questions that everyone always asks when you look at the moon is, why is the moon white? And so when we see our dust plume, we're expecting some white color. But for those who have equipped spectrographs, you'll actually be able to see a lot more detail. And of course, I always like to think of the white color as more a result of our own inability to discern details in gray, which is kind of what the moon has a lot of. Of course, the gray basalt is a big impact there, but what we will probably see is going to be, uh, I'm guessing, a little white mark, poofing off of one end. That would make me very, very happy. And of course, I will just say, because we're getting close to the time of estimated impact, I've been keeping an eye on the timing, and the last I heard, we are still looking at Eastern daylight time of 2:35 a.m., which by my clock is in about 5 minutes. So if anybody starts to see a streak in the image, uh, that means we're very, very close. I do have 1 second exposures going. So just in case anyone's curious, we are currently using an S-Big CCD camera with a neutral density filter. This is an ND5 filter, and we're taking 1 second exposures because the moon is very, very bright. And we're trying not to destroy our CCDs. Bruce, do you have an imager set up?
I do not, because from my particular location, actually, I cannot see the moon. I have trees in the way, unfortunately, so I am not. I was actually going to reach out to Seneca and ask him if there's anything or anyone from the Barbados Astronomical Society who is imaging the moon tonight.
I think our president, David Marshall, is currently imaging the moon. We have some passing clouds. I'm not sure whether he's going to have a clear and consistent view, but we've got at least one telescope looking at.
Now, is the moon higher up in the sky from where you were seeing it?
Uh, Fairly, I think. Ordinarily, I can see it for the first couple of hours out this window, and it's clear of that at least. So I think it's fairly high up. I'd have to check specifically.
Yeah, of course, in Toronto, we started off quite low with the moon, and it's getting pretty good. As we get later in the evening, the moon gets higher and higher, so we're about 34 degrees altitude at the moment.
And luckily from the Allen Carswell Observatory, I imagine you have a clear view of the moon.
We do, and actually, while we're waiting for our impact, I'll just very quickly, of course, the data is gathered regardless. I'll go up and show people where they can have a look. And on the way, if anyone is enjoying this impromptu broadcast, I will just remind you that we are hosting our one and only paid event of the year, our major fundraiser, the Astro Fair 2026, this August 29th. Now, if you'd like to know what the sky looks like, all you have to do is go to our website, science/observatory/astro, and go to observers, and you can click on the all sky camera. And this will let anybody see what the skies look like right now. So we are quite clear, and that bright headlight is actually not a football stadium light. It's the moon.
That's amazing. That's
So
amazing.
we can see the moon up over the domes. Of course, you can't see the telescope because it's pointed at the moon. Now we'll come back down, of course, to try to get the best possible view here. And as mentioned, wherever you are in the world, if you can see the moon, even if you don't have a telescope, just hop out and have a look. You never know, you might get lucky. Maybe it'll be, as Bruce was saying, one of the spectacular ones.
Absolutely. And I think it's important for listeners to understand also something you said earlier, which is you actually have a filter called a neutral density filter over the telescope to darken the image of the moon. It must be so bright in that 1 meter telescope.
Yes. And that's something you do have to watch out for if you have any kind of extra optical assistance. You can take an object that's normally safe to look at and make it not safe to look at.
Yes, at the Killarney Provincial Park Observatory, sometimes we actually hand out sunglasses to viewers who are going to see the full moon in the telescope. It's too bright and actually can become a little painful if they don't have some kind of protective eyewear.
Yes, keep your eyes safe, everyone. And this is obviously a very exciting observation for science. A lot of astronomers and amateur astronomers might be collecting imaging now. Just as a little note, if you are collecting imaging, there is a research team who's actually asked everyone, astronomers and amateurs alike, to consider submitting their data for this August 5th Falcon 9 upper stage lunar impact. The research team is led by Benjamin Fernando from the Los Alamos National Laboratory. And if you do a quick search for him, he's actually got an online sort of submission portal. And they've made a call for everyone who can take data or take imaging. If you do manage to see something, consider sending it in to them. And they can use it to tell all kinds of things about the moon, because right now people are still debating how big the plume will be, what the materials might be made of, and there's all kinds of interesting science we can tell from the collision, actually. Is there anything you're hoping to find out, Bruce?
I'm just curious to see how well we're able to predict these things. I think the science of aerodynamics and telemetry that we're going to get back from this would be quite fascinating. I think it's amazing to understand the density of the moon and how when we hit it at certain certain projectiles, man-made or in fact natural, because of course the moon gets hit by objects all the time. It's interesting to understand and predict how much impact that will occur. And the more we learn about the moon, the more it'll help us understand as we begin to return to the moon, in fact, actually land people upon its surface.
Yeah, absolutely. And of course, this, being a bit of an amateur astronomy extravaganza with all the telescopes trying to view it tonight, this is a wonderful collaboration between amateur and professional astronomers that I think a lot of people will be able to really enjoy. And I love that also it was a very unique and novel way of tracking a quite large piece of space debris. Because this Falcon 9 rocket booster is extremely large. So if you see it stacked up next to humans, there was like, what, 30 humans wide or something?
It's amazing. It's quite
Yeah, it's a
amazing.
very large object.
And I don't think people appreciate how fast and how powerful those combined items, putting in mass and putting speed together, can become. I mean, when people look in the sky and see a meteor, and the Perseid meteor shower is coming up next week on Wednesday evening or so,
Yes.
that streak of light is something moving in the sky about 100,000 to 200,000 kilometers per hour. And this is moving, what is it, about 7,000 kilometers per hour? But those
Around
streaks,
there for the last estimate. Yeah, it is
yeah.
very, very fast.
But what people don't realize is those streaks of light, the bright streaks of light you see in the sky, are made up by particles about the size of your thumbnail. And that's a little tiny piece of dust. Now, of course, it's burning up in our atmosphere, so we're seeing the result of friction and heat from our own atmosphere. You don't have that on the moon, but you are going to get something of sufficiently larger mass than a piece of dust. So it'll be very interesting to see how powerful this impact might be.
Well, we can obviously give it our best try. Now, I will say as well, even if we don't see it in this image, that doesn't mean it's not there. And that's because one of the things that happens in astronomical images is something called data reduction. And that's where you go into the image and you actually change the light levels pretty substantially. So at the moment, I can see the moon quite well, and I'm just going to do what's called a screen stretch to bring out any extra brightness around the edges. And there's a bunch of very, very detailed types of um, this kind of trick that you can do when you have the raw data files. You can also eliminate noise from your data, and you can bring out a lot of extra detail by sometimes, well, not in this case, stacking images together. So everyone can probably see that I can get more image detail out of the surface of the moon from various parts when I shift the what's called the screen stretch, which is telling the image to display the pixels in a different way. But all the data is still there. Um, so what we're seeing now is, of course, the edge of the moon that has Einstein crater on it. And let's just have a look and see if we can confirm if the impact's happened yet. We're all hoping that it will be, so we should have 235 is what it says on the last calculator I saw. Do you have any different ones, Bruce?
No, I'm still going by that 235 number.
Then it should be there.
It should
Um,
be.
and now let me just go ahead and mark it for everyone. So this is an interesting area of the moon. We're looking towards, of course, that Einstein crater, as I mentioned, and I'll just see if I can mark it through here with an annotate function. It
I'm
should
also
be
scanning the
right
web
in,
to see if anybody else is seeing impact at this time. And ironically
right
enough,
about
someone,
there-ish is where we're hoping we'll see something.
yeah, not yet. See anything
Now
there
I
at
said
this
it
time.
could be in the data.
Yeah.
It could have been a very tiny plume, and I did hear a couple people early on. I told our crew, when people were estimating the size of this dust plume, there was a disagreement amongst a lot of different astronomers about whether or not the dust plume would go completely sideways and actually not kick up hardly anything, um, which is a distinct possibility if the rocket impacts in a certain trajectory.
Is that suggest, Dr. Hyde, that it would actually push the dust behind the moon in a sense from our perspective?
It would push the dust along the surface of the moon rather than straight up.
Right.
And the interesting thing about that is that if it did that, it should leave a pretty good mark on the surface of the moon. And of course, we have a wonderful lunar reconnaissance orbiter capable of doing all kinds of great imaging, and that will be taking some pictures around the area of Einstein crater where the impact is supposed to have happened.
It will have a unique perspective that we cannot attain.
Well, not without not without a rocket booster, and it looks like this rocket booster is you know, one that won't be showing off
Any longer.
any longer. Yeah, this is a rocket booster that is not going to be reusable.
Definitely.
Um,
I'm checking other sites as well around the world of people capturing it, and interesting enough, also I've not seen anyone display any kind of resulting impact. And funnily enough, they're also doing stretching of the images to see if they can obtain more from the data, and the same results, nothing so.
and of course, this will be making a few theorists very happy, especially the ones who predicted almost no plume.
Hmm.
So it's one of those great times where you can always make someone happy, but you're never going to make everyone happy.
Exactly.
Um, and the fact that this, of course, impact will leave a new permanent crater on the moon that will be potentially visible to telescopes is something that's really interesting, of course, because the collision is accidental. They were not running into the moon on purpose.
Exactly. I wonder if some people feel there's an ethical dilemma in that as well, that maybe we shouldn't be leaving our marks on the moon to that extent.
Yeah, and that's definitely something that's been raised by a lot of folks about, the near side of the moon is a face of the moon that all of humanity has had and shared for a very long time. However long you want to think humans have been here for. I go back to the was it Denisovians? But we've always had this face of the moon, and the impacts that are on its surface have all been naturally created by, of course, various asteroids and other objects. This is going to be an artificial impact, not the first one by any means. There have been quite a few really notable, actually, lunar impacts. And I think some of them are actually listed in the paper by um, Benjamin Fernando et al. I think they had the first artificial impact on the lunar surface was all the way back in 1959, and they were deliberately colliding with the moon on purpose because that was a lot easier than going there. And if you collide with the moon and kick up enough dust, then you can study the dust that gets kicked up with spectrographs and photometry, um, which is what we were hoping would happen this time, but we don't see a big plume of dust.
Not yet, not yet. And I think it was also important for them to aim their projectiles at the moon in that time in advance of first lunar spaceflight landing astronauts on the surface, because there was a real fear by some of the scientists that you might land a spaceship on the surface of the moon only to discover that that surface is full of a kilometer thick of dust and just pull yourself right under a dust cloud 1,000 meters deep or so, and that would not be a very good experience for those astronauts. So, landing those objects on the moon to that extent not only helped scientists understand the makeup of the moon itself, but also helped pave the way to ensure safety for those astronauts.
Yeah, and I mean, not to say that lunar dust was not a problem, but
Indeed.
because the gray and white that we see, all that basaltic dust, there is a fair layer of this gray dust all across the moon, and there's worries about it being toxic, and of course, many stories from the astronauts about the dust just getting into absolutely everything. Um, so it's would be interesting to see if the collision did manage to entirely dissipate all of its energy alongside the moon, creating some large surface feature, or if the collision actually somehow managed to miss. That would also be pretty funny.
Exactly. Absolutely.
Uh, Seneca, do you have a favorite scenario?
Sorry, I missed a little bit of the last part of the conversation.
Oh, no worries. I was just wondering if you had a favorite scenario for, of course, the lunar collision. We were debating about what could have happened with the Falcon 9, and whether or not it might have been able to dissipate its collision entirely along the surface.
Well, just for the sake of spectacle, the one scenario could be just that we're not looking at the right view of the image to see the ejecta from this perspective.
Yeah, and that's actually a good point, because they did mention that depending on your location on Earth, your view of the moon actually does change a little bit. And this is a really interesting one because, of course, the moon has one side facing the Earth all the time. That's synchronous rotation. However, all the parts of the Earth viewing the moon do not get to see exactly the same parts of the moon along the edges, because there is this little bit of a difference along the edge of the moon, that means that there can be some people who can see just that edge and some people who can't see that edge, depending on where they are on Earth. And so there are some locations listed. Now, in Ontario, in theory, if they're right about where it collided, we should be able to see it. However, if they were wrong by a few kilometers or something, it might just be, as you say, over the edge of, perhaps just over the edge on the other side of Einstein crater, or maybe it was back up past, one of the other ones there. So you have basically in a row, you've got Einstein, Moseley, Bell, Robertson, and so it could be, a few craters up or something, as opposed to exactly at the position listed on the charts. Very fun.
Mm-hmm.
And in any case, we have gotten to see some lovely lunar imaging.
Absolutely. And it's quite fascinating to see the degree and quality of imaging that is produced from the 1 meter telescope. They can actually see just to the right, there's a crater there. I'm not sure of its name. Yep, a little lower down. And it has a lovely blanket of ejecta emanating from the center of the crater in
Oh
the middle
yeah,
of the sea there.
there's some really great objects around, especially on the moon. Um, and we have a bunch of really good lunar maps um, that we can pull in as well if we want to bring in some extra lunar fun facts. Now, as mentioned, we do have a few in here. One thing you'll be able to pick out right away, of course, is the difference between the lighter regions and the darker regions, which is a very common one in astronomy. The darker regions are, of course, the Mara, or the ancient lava fields of the moon. And I think you had some fun facts about the Mara, didn't you, Bruce?
Just in terms of enjoying the blanket of ejecta upon it, but the mare is made up mostly of basaltic material coming from lava or pockets of lava ejected out onto the surface and then flooding the surface billions of years ago, and it's quite an amazing thing to see. Back in of course, the ancient times, people used to look up at the moon, and while they could not distinguish necessarily individual craters, at least they believed most people couldn't discern them, they definitely could see the darker areas, the mare or the mare on the moon, and they thought they were seas. They thought that maybe they were filled with water, and of course, we now know that they were, in a sense, dried up beds of lava, of molten lava, and made up primarily of basalt. Quite something to see.
Absolutely. And of course, driving all around on the moon would be really, really fun.
Absolutely,
I
as the astronauts proved.
exactly. And I know they're planning to come up with a new lunar vehicle for landing, but they should definitely come up with another rover. I think that would be a really great idea if you're going to do um, a new moon mission, being able to drive around, see everything.
Absolutely.
And now let's see if I can find a couple crater names. I think I've got um, a fair number of lunar craters that we can try to get to. Now, I think the one in the middle was Kepler crater. From memory. So the grayish one that's sort of in the middle of the image, with the nice ejecta paths, and those
Hmm.
streaks leading out, of course, were ejecta created from the collision. So this might be a feature that we could see from that collision that just happened with Falcon 9, or didn't. If they, for example, send the Lunar Reconnaissance Orbiter over and we can get a good picture of that side, any streaks like this would be easy to spot even from a larger distance.
Yeah, I
So
also confirmed that it's Kepler A, as it's called.
Kepler A, right, Kepler A. And the one above it with the interesting pattern, that's the Aristarchus, I think.
Yes, it is.
And a lot of these craters have really fun names. So if you find one, usually you can use a good lunar map to kind of find your way around. And there's a few online that you can get. I think I'll just give a little call out. There was one that was it's Lunar Map is actually the name. It's just all one word, Lunar Map. So if folks are feeling ambitious and feel like looking for a lunar map, that's probably one of the good ones. There's also one that I've linked on our observatory page under tools. So if people do want to follow along with that, I'll just show you where it is really quick. So we've tried to put everything people might need who want to go observing either at our observatory or somewhere else. And I've put in some moon maps here from NASA. And so they've got a moon map website as well as some printable ones so you can download and give yourself quizzes on which craters are which. And that's also where I recommend people to get the all sky camera if they want to see what our skies look like tonight. And it looks like I'm seeing a few messages from some of the other research group members that other people are also not seeing the plume. But I still don't have any confirmation on the impact. So I'm not sure if Lunar Reconnaissance Orbiter is going to, um, how fast they're going to be able to get there.
Yes, it's obviously we can't say it hasn't happened until we've got confirmation it has or has not.
Exactly. So we'll be accurate and say we don't know.
Perfect, perfect. But taking a look at how the Einstein crater is positioned, I mean, from our perspective, it is so almost perpendicular to us. It's right at the limb of the moon. I wouldn't be surprised if we don't see the plume. All things being told, and based on our discussions of this evening, maybe that plume is just sort of pushed off away from us in a way we just can't really see it.
Yeah, that's definitely a real possibility. And it looks like, other places throughout the northern hemisphere have had similar problems, at least from the messaging that I am seeing online.
Hmm.
All right. So it looks like we are at 2:55 a.m. The moon still looks fabulous. And of course, Aristarchus looks fabulous. The cratering looks great, but there does not appear to be any solid plume from the Falcon 9 impact. You've heard it all here first, folks. It is true. We, in fact, do not see it. That doesn't mean it's not there. It just means that we are not able to detect it with the 1 meter at the LNIA Carswell Observatory. So it must either be smaller or not there, or somewhere we can't see it, which is a good range of possibilities, I think. As Seneca mentioned, just out of view is a real possibility, but it does restrict how large the plume could have been. So those folks who were hoping for a truly gigantic poof of lunar dust, I think they can safely be disappointed.
As you said earlier, it's a confirmation of a negative sighting.
Exactly. We'll have a positive confirmation of a negative sighting, and even better, it's created another mystery. So now we have to figure out what really happened. So lunar reconnaissance orbiter imaging might be needed. I'm looking forward to seeing what happens in the next few hours, actually, as scientists continue to try to gather data and see what they can find.
Absolutely. Did you want to try one last screen stretch, just hoping against hope?
Sure, let's do it. First, I'll give it a little shift because, of course, we're on the moon. So I do need to make sure that we. Oh, actually, no, it's in a good spot. We'll just do a screen stretch to push the brightness, and again, all this data is in here. So if we process it and adjust the levels, maybe we'll be able to bring something out that wasn't there before.
Now, Dr. Hyde, are you using any AI in your development of these images?
I'm glad you asked. Absolutely not. Well, it's very important to note that we do not use any Gen AI or LLM AI, but we do have home written quote unquote artificial intelligence routines that we use for gas and dust tracing, galactic archaeology, and other implementations. And those are heavily related to what's called machine learning. And they are technically under the field of AI, but the field of AI is very, very, very big. And so while we don't use any LLM or Gen AI, we do use home-crafted techniques, which we train and control ourselves, which can be great at doing things like reducing noise and picking out faint structure.
Now, Dr. Hyde, at the Killarney Provincial Park Observatory, we prefer no one to use AI or LLM to generate any of their images. What is your perspective on why that could be a bad thing?
Well, you're going to introduce errors. Anytime you use a LLM or a Gen AI on an image, it's going to be doing interpolation of some kind, possibly copying from a database that it has access to or other data that it has trained on. So you could end up with pieces of someone else's image in your image. Um, and you could end up with somebody incredibly famous, like, of course, the astronomer David Malan, whose astrophotography I think is recognized around the world. Um, you could end up with one of his images in your image, and you would never know, and you wouldn't be able to cite him. So
Right.
you would then not be able to ever publish that image because you would have no way of knowing where the interpolated data came from, what it had in it. Was it an artist's interpolation? Was it someone's science results? You would never be able to cite them and give them credit. And it would also mean that your image was not accurate. So if you took an image at a certain time, like right, what we're trying to do, to capture something like we're trying to capture, we want something that's going to happen tonight. And it didn't happen, and that's a significant result. But if we were to process it with an AI or an LLM that was trained on a wide variety of data, telling it we were looking for something, it might then introduce perhaps some of the plume and collision results seen in, for example, your Jupiter data. So you could end up with a comet colliding with Jupiter, but mixed in with your lunar data. So you could end up with all kinds of very strange inaccuracies on purpose and on accident. And it's got a lot of other weird things that we could probably talk about for many hours.
Yes. Sounds like something to avoid at all costs.
Absolutely, and that's, the costs are pretty high. So yes, absolutely. All right. So I think since it is now officially 3 a.m., and I still do not see it. Um, yep. I'm just going to yep, I still don't, definitely not. Let's try going to the bottom of the
Oh yeah,
distribution
there's nothing
curve.
there. There's nothing
Yeah,
there.
I might see a star. I
Or
think I see
two.
a star. A few cosmic rays, possibly a star or two. We'll have to process the data to be sure, but it doesn't look like we're getting any large plumes. So we're going to call it a very successful non-detection and a very fun discussion of the moon. I look forward to sharing these science data with the research team, and I hope you all have had a lot of fun tonight.
Absolutely. Thank you so much for hosting us, Doctor.
Yeah, I had a
Thank you,
great time.
Bruce.
Thanks very
Thank you,
much.
Seneca. Wonderful to have you join us tonight. Come back again anytime.
Will do.
And huge thanks to Hector and Manish, who went out and took the flat fields, I think near midnight. And a thanks to Nicole, who helped to set up the telescope earlier this morning. All right, everyone, you have been listening to the impromptu Falcon 9 live stream for the moon by the Alan I. Carswell Observatory at York University in Toronto, Ontario, Canada. We hope you have enjoyed these wonderful pictures of the moon, even though there was no dust plume. And if you would like to find out more about the observatory, or of course, join us for our wonderful Astro Fair 2026, running this year, August 29th, our one and only fundraiser. Should be a lot of fun in Toronto. Come along. All the information you've seen and the live imaging screen capture is at yorku.ca/science/observatory. All right, everyone, thanks for joining in and have a good evening.